Now, another question under this says the sum of the first n terms of an AP is 252. If the first term is minus 16 and the last term is 72, find the number of terms in the series. Now, let's take a good look at this question. The question says the sum of the first term, the first n terms of an AP is 252. If the first term is minus 16 and the last term is 72, find the number of terms in this series. Let's go again. The sum, or let's do an analysis of this question. The sum of the first n terms of an AP is this. Now, there's a problem here. We don't know the n term. It is not defined, so we don't know it. And then now said, if the first term is minus 16, and they gave us the last term also to what 72. Earlier when I was teaching you series, I told that we have finite series and infinite series. Now, this one is finite because it is defined. We know the last one. So, for infinite, I told you that it's not defined. So, we are going to approach this one in a different way. And now, so they said that find the number of terms in the series. That is this n, we are looking for it. We have been given the sum of those terms. It was 252. Now, let's proceed. So, given Sn to be what? 252. We have our A to be what? Minus 16. And our L, that is unusual, right? But then, the last term is a finite term. This term is defined. So, we have it as what? At 72. So, we are looking for n now. Our n now is unknown. So, we don't know it. So, how do you go by this? You see the sum we are looking for. We have been given A, we have been given L. So, but then, you might want to think that I gave you this formula to be what? Sn bracket 2a plus n minus 1d, right? But we're not going to use this because we have the last term already. We have been given the last term, so we're not going to use this. Rather, we're going to be using Sn is equal to n over 2 bracket a plus l and the last term. So this is what we're going to be using in this question. So we're given the sum of the terms we want 252. The number of terms is unknown. We don't know it, right? So we're given our A to be what? Minus 16. And then the last term is what? That's plus 72. Okay? So we have 252 is equal to n over 2 minus 16 plus 72 is going to give what? That's 56. That's 56 already. So now we have 252 is equal to 56n over 2. And we cross multiply. We're going to have 252 times 2 is equal to 56n, right? So if we divide both sides, or let's multiply this, we're going to have this is 504 is equal to what? 56n. So divide both sides by 56, we're going to have our n is going to give us what? 9. So our n is what? Our n is 9. So let's proceed with geometric progression now. So we are done with solving some examples under arithmetic progression. So I want us to look at the other one, which is what? Geometric progression. So, geometric progression. So I want to define a geometric progression. A geometric progression GP is a sequence in which two consecutive terms differ by a multiple. How do I mean? Let's look at an example. I told us earlier for arithmetic progression, that one is going to be what? 1, 2, 3, 4. Then I gave us what? I gave us n. N plus 1, right? If you remember, that is when it's equal to 1, it's equal to 3, and the likes. But this one is different. That means the numbers are increasing geometrically. So, an example of this is what? 5, 10, 20, 40. If you observe, the difference between this and, in this case, all we do is what? We do division. We don't do subtraction, okay? So, and then our difference here, we don't call it difference. We call it ratio. We call it common ratio, not common difference. In AP, we use common difference. In GP, we use common ratio. So, but logically, if you have to look at this, this one is, if you multiply 5 by 2, you get what? 10. If you multiply 10 by 2, you get what? 20. If you multiply 20 by 40, by 2, you get what? 40. We can proceed further by multiplying 40 by 2. What are we going to get? 80. If you multiply 80 by 2, we get what? 160 and the likes. The list is endless, so we can continue. But then, the ratio here is what? Is 2. The common ratio is what? Is 2. I mentioned the word common ratio. So let's simplify this now. So we have T2 over T1, right? This is T2, this is T1, this is T3, the third term, this is T4. We still maintain this. So for our T2 is what? 10 over 5. It gave us what? 2, right? So our T3 minus T2 is 20 over 10, and that is what? 2 also. Common ratio. Let's try the third one. T4 minus T3, 40 over 20. 2. As you can see, it is the same. Common ratio. Now, let's look at our formula. There's a formula in which we use to approach any question related to GP. And what is that formula? If I limit GP, we use T n is equal to ARN minus 1. We have to know all these things. It's different from AP. Our AP earlier gave us Tn is equal to A plus n minus 1D. See, they are different. So because we are using a different approach, and because this one is increasing geometrically, while this one is increasing what? Arithmetically. And also I told us also that in this one in this one we divide, while in the other one, in the AP, we do what? We subtract. So let's look at an example. So example 1. Under this, the question here says that the fifth term the fifth term of a GP. Now, it's not AP, it's GP, is 48. And the eighth term is 384. Find the first term and the common ratio. Before we proceed with this question, let's look at how we can generate the first term, second term, third term, and the likes. Let's see it now. So before we proceed with this question, so we have Tn, right? To be what? A r n minus 1. Let's assume we're given n. Let's look for when n is equal to 1, when n is equal to 2, 3, 4, okay, and 4. Let's stop at 4. Like we did for arithmetic progression. So when n is equal to 1, that is the first term, what are we going to have? We have T1 is equal to what? A r n minus 1. What is our n? 1 minus 1, right? So our T1 is equal to what? A r raised to power 0. And from normal mathematics, n raised to power 0 is what? Is 1. So that means our T1 remains A. Okay? So when n is equal to 2, so Tn is equal to A r. Sorry, let's just go directly. T2 is equal to what? AR2 minus 1. So my T2 is equal to what? AR. Okay? So my T3 is what? AR3 minus 1. So my T3 is equal to what? AR raised to power 2. So you can see this one now. So the first one is what? T4 is equal to AR4 minus 1. And that is going to give me what? AR raised to power 3. You can just proceed like that. So I hope this one is clear enough. You can do T5, you can do for T6, T9, and the like. Or before we proceed, if I tend to look for T12 now, T12 is going to give what? AR raised to power what? 11. Simple as that. So let's proceed now with our question. So our question says the fifth term of an AP is 48 and the eighth term is 384. Find the first term and the common ratio. Okay? So our solution. So the fifth term, that's T5, is what? Is 48. We have T8 to what? 384. So we're going to look for our first term, that is A, unknown, and our common ratio, that is R, not D this time, R is what? Is unknown also. So from the breakdown I did earlier, our T5 is going to give us what? AR raised to power 4 now is equal to what? 48. Okay? So our T8 now is going to give us what? AR raised to power 7 is equal to what? 384. So what do we do here? Earlier we did elimination for a question like this. Now we're going to eliminate this one by doing what? By dividing them. And how do you do that? So this is our equation 2. This is our equation 1. So let's rewrite it in that order. Equation 2 minus equation 1. Because once we eliminate our A to get our R, okay? So like we did arithmetic progression. So we have AR raised to power n is equal to what? 384. And then we have AR raised to power 4 is equal to what? Is equal to 48. Okay? So from here, our A, if we are dividing now, our A is going to cancel out. So 384 divided by 48 is going to give me what? It's going to give me 8. So I'm going to be left with R raised to power 7, R raised to power 4, raised to power, is equal to 8. From the law of indices, if you have something like this, what do? We are going to bring this 1 to the top, and then if I'm going to rewrite this, it's going to give me what? R to the power of 7 minus 4 is equal to what? 8. So my R is the power of 3 is equal to what? 8. Now the cube root of 8 is going to give me what? It's going to give me 2. The cube root of 8 is going to give me what? 2. So I have for my answer now. Therefore, I will say therefore my A. Okay, we've not gotten our A. Let's get our A. We've gotten our R. We need to get our A now. So let me substitute our A, the value of our R, into equation 1. Okay. So what am I going to have? I'm going to have AR is equal to 48. I'm going to have A. Our R now is 2 to the power of 4 is equal to what? 48. Now A, 2 raised to the power of 4 is going to give what? 16. 48. So 16A now is equal to what? 48. That means my A, for me to get A, I'll divide both sides by 16. So my A is equal to what? 3. Therefore, don't forget to note this. Therefore, A is equal to 3, and then my R is equal to what? 2. As simple as. So we have this T5 is equal to 48. Our T8 is equal to what? 384. So I told us earlier that our T5 is the same thing as what? AR to the power of 4 is equal to what? 48, and that is what? Equation 1. So our T8 is equal to AR to the power of 7 is equal to 384. That is equation 2. So for us to get our answer, we have to eliminate one of the unknowns, right? And that is A. Because from here, A is still going to leave. So now I told you earlier that we're going to be doing our division. In AP, we did subtraction, but here we're doing division. Okay? So if A cancels A is going to be eliminated. So I'm going to be left with what? R to the power of 7 and R to the power of 4. Then on division, 3, 8, 4, and 3 and 48 is going to be what? 8. So R raised to the power 7 is equal to R raised to the power of 4 is equal to 8. So from indices, R, when we have something like this, it's going to give us what? Subtraction. So R to the power of 7 minus 4 is equal to 8. And from here, we're going to have the cube root of what? Of 8. And that gave me what? 2. So we want to substitute R into equation 1 because we want to get our A. So if we put R into equation 1, we have this. Let me notice as what? Equation 1. So you have this, and then 2 to the power of 4 is going to be what? 16. That is 2 times 2 times 2 times 2. Give me 16 here. So, and then on further division, it's going to give me what? 3. And then we have solved our question, and that is done.